if you go back to the first module when we started talking about probability, and when we defined probability, we also defined odds. So if the probability of an event is A, then we said the odds of the event would be P over 1 minus P. So if the probability is P, the odds are P over 1 minus P. Mathematically, what happens to P over 1 minus P as P gets close to 1, I've only drawn it up to 0.8 here, but as P gets close to 1, this thing is going to go off to infinity. So that's useless. But when you contrast the odds, so this is the odds, when you contrast the odds versus the probability, you see that down here they look like they are almost the same. And in fact, let's amplify that. And so now we're going just to 0.1. Instead of 0.5, let's get down to 0.1. We see that they do start separating a little bit. But down here, they're still very close together down here. So once again, this is the odds, and this is the probability. So they are pretty close together when we're less than 0.02 or so. Let's look at them tabularly. Here is the, if P is between 0.02, at 0.02, the odds are to 2 digits, they are the same. And you can see that they start coming apart down here at 0.09. So up to 0.1 or so, they're pretty close to each other. If you look at the difference, delta is the difference, so this column is the difference. You see that to 2 digits, the difference is 0. It's only down here that you start seeing a difference. What about the relative difference? Well, if you are trying to approximate P by 1 minus by the odds, then you might want to look at this difference divided by P. Expressed as a percentage, there's your percentage error. It's 2%, 3.09, and so on. Actually, it turns out that this is exactly the same as this column. Just mathematically, it turns out that those are the same. It looks different because I've multiplied this column by 100, multiply that column by 100 to get this column, and so we're getting more digits of accuracy. That's all it is. On the other hand, if you are trying to approximate the odds by the probability, then as a measure of error, you might want to look at the difference divided by the odds, and then that you get your relative error that way. And here it is. So that this column gives you that relative error. So it's 2%, 3%, 4%. It's 5% down to here. Once again, an oddity, mathematical oddity, is that this column here is the same as the first column multiplied by 100. So what this says is that it's a 10% error at 0.1, and this one says it's an 11% error. So your maximal error, if you restrict yourself up to 0.1, is going to be, relatively speaking, 11%, 10%, that kind of stuff. This is just a mathematical consideration. Very often, odds and probabilities are used interchangeably. They are not the same thing. When we're in this low domain here, when we're talking about rare events, then if by rare event you mean less than 5%, you see that your maximal error is less than 5%. So judge that if that's good enough for your context or not. We'll see later in the course, especially when we get to case control studies, that odds are very useful, especially relative odds, and we'll revisit this issue back then.